Okay. So a couple things that we need to talk about. Just they're small topics, they're add-on topics, but they're things that you need to know. And the first one we need to talk about is restrictions on domain and range. So in IM3, you talked about restrictions on the domain, and what you probably called them was excluded values. And they were things like if you had X plus Y, let's make it X plus 4 instead. Let's over X. If you had something that looked like this, then your domain, you would say that X could not equal 0. Because if X equaled 0, what happens? It's undefined because why? Because the denominator would be equal to 0, and we can't have a denominator equal to 0 because we cannot divide by 0. We cannot take something that exists and make it not exist. So your restrictions on the domain are these excluded values. That's what a restriction on the domain is. So if I had something like the square root of X minus 3 all over X plus 3. What are my restrictions on the domain? Okay, I can't be -3, right? Because if it's -3, then this becomes 0. So I could say that X cannot equal -3. If I want to write it in interval notation, I could say we go from -infinity to -3, union with -3 to infinity. This little thing means the union of, or the combining of. So in interval notation, it may say from -infinity to -3, u -3 to infinity. Last year, the last kind of thing that we talked about was with these is that if you had something like this, f of x equals 2x over x squared minus 7x, what do I do with the denominator? Hold on, I just unplugged my microphone. And we're back. Okay. All right. So what do I have to do to the denominator? What do I have to do to find my restrictions? How do I find the zeros? What do I do? Anytime you see an x squared, what's the thing we pretty much did with it last year? Nope, because we're not solving both sides. When you see something like this, an x squared, factor it. So, do these have any common factors? Well, yes, they both have an x. So I can factor the denominator. Then I can find my zeros by setting each piece equal to 0. And my two zeros are x equals 0 and x equal 7. Those are my restrictions. Those are what it cannot equal. And if I was doing interval notation, I would say -infinity to 0, union with 0 to 7, union with 7 to infinity. Last year, we would just put something like all real numbers except x cannot equal 0 or 7. Same, I mean, it's the same idea. So it's just a little bit about writing it. Now, restrictions on the domain are pretty easy. Set the denominator equal to 0. Doesn't really boggle the mind that much until we get into something like that. And at first glance, it looks pretty obvious that, oh, it could be whatever. But it can't. Because what can't I have inside a radical? What's not permitted inside a square root? A negative. Because if I have a negative, then it becomes a what? Remembering from last year. If I have a negative inside a radical, it is a imaginary number. So I need to find what values allow this to be positive. And the easiest way to do it is to find the zeros of this first. So I'm going to do x squared minus 81 equals 0. X squared equals 81. Square root both sides. And remember, if you take a square root, you must include. And this is going to give me 3 separate ranges. So it's going to give me from negative infinity until negative 9. It's going to give me from negative 9 to 9. And it's going to give me from 9 to infinity. But what I need to do is I need to find when is this going to be positive and when is this going to be negative. So what I'm going to do is I'm going to take a sample from each one. Like from this section, I'm going to take a number between negative 9 and negative infinity. Pick one. I don't care. I'd choose something like negative 10. 10s are easy to work with. So I'm going to choose negative 10. Choose something between negative 9 and 9. What's the easiest number to work with between negative 9 and 9? 0. Always choose 0 if you can. And between 9 and infinity, I'll pick 10 again. So let's go back up to my function and plug in negative 10. So the square root of negative 10 squared minus 81. I don't even need to solve this. I just need to know, is it going to be positive? Well, what's negative 10 squared? Negative 10 squared? 100. 100 minus 81, is that a positive number? Yep, so that one works. Plug in 0. 0 minus 81. Is that a positive number? Nope. And 100 minus 81. So these two worked. This one and this one. What in the middle didn't work. Now, the only other thing when I write out my final answer for the restrictions on the domain is I have to look, well, what about negative 9 and 9? Do they work? Well, if I plug in 9, I get 9 squared is 81. 81 minus 81 is 0. Can I take the square root as 0? The square root of nothing is nothing. Sure, I can. I can't take square root of a negative number, but I can take square root of 0. So these work. And because these work, instead of a parenthesis, I'm going to put a bracket to let people know, hey, this includes 9 and negative 9. Yeah.
So even when we chose 0, anything in between negative 9 and 9 would work?
Yes. Yeah. Anything. So like if I chose 2, that would have been 4 minus 81, still a negative number. Chose 5, 25 minus 81, still, you only have to choose one sample from each compartment. Yeah. So this is my domain. What would my range of this function be? Going back to this original function here, what would my range be? What results could I get?
You can get the results.
True, but not in the way you're thinking. What can I never get with a square root? Can I ever get a negative number with a square root? So my range is going to be from 0 until infinity, and 0 is included. I could get 0, but I can't get a negative number. So you really have to think about these. Sometimes graphing them helps, because you can see on a graph, kind of like we did on that one card sort. So using a graphing utility is another way to do that. So that's restrictions on the domain and range. Let's talk next about composition of functions. Commonly referred to as Fogg and Goff. F of g of x, g of f of x. It's simply a way to plug one function inside the other. So what f of g of x means is take the g of x function and plug that in inside the f function. So f of g of x means take the g of x function, evaluate it, and then evaluate the f of x function with what you get. So g of f of x is the opposite thing. Take the f of x function and stick it in the g of x function. So if I have f of x equals x squared plus 1 and g of x equal to 3x minus 1, and I ask you to find f of g of x, what I'm asking you to do is to take the g of x function and plug it into the f of x function. So I want you to take this part and I want you to plug it in for x. So I want to plug in 3x minus 1 for x in the f of x function. So I substitute in 3x minus 1 for x. I want to talk about this guy real quick because common mistake. Remember, you cannot distribute that squared because what this is saying is 3x minus 1 times another 3x minus 1. That's what 3x minus 1 squared means. We still have a plus 1 out How do I multiply these two binomials? We had a little word for it. Nope, other F word. FOIL. So 3x is 9x squared. 3x and -1, -1 and 3x, -1 and -1 is +1. You multiply. So 9x squared minus 6x plus 2. Now, if I look at the other side, g of f of x, it says take the f of x function and plug it in for x in the g of x function. So I substituted x squared plus 1 in for the x. Distribute the 3. And my final answer, 3x squared plus 2. So g of f of x and f of g of x are not the same thing. You don't get the same result ever unless they're the same function. No, there could be situations where you could get the same thing. But generally speaking, you don't get the same thing. Okay, the last thing I want to talk about is functions and inverses. We had a test to determine, is it a function? And I'm going to be super impressed if any of my pre-cal kids can remember what that was. How can I test if something's a function? There's a specific test. Unfortunately, I kind of expected not to remember, but is it a function? We have a thing called the vertical line test. That's fine. What did the vertical line test tell us? How did it tell us if it was a function or not? Was this a function? No, because with the vertical line test, if I drew a vertical line, what did it do? Why was this not a function? Yeah, it hit the graph twice, meaning that for one x, there were two possible y values. And so that's no good. That's not a function. We also have a test called the horizontal line test. And the horizontal line test determines, does it have an inverse? So the horizontal line test is exactly the same thing as the vertical line test, except it's horizontal. So if I have a graph like this, and it hits it more than once, then we can say it doesn't have an inverse because it fails the horizontal line test. So just like if it fails the vertical line test, it's not a function. If it fails the horizontal line test, it doesn't have an inverse. If it passes both, we say the function is one-to-one. Meaning that for any x value, I get exactly one y value. For any y value, I get exactly one x value. That means like if I choose x equals 5, I know I'm going to get 4 for y. Okay. If I choose 5 again, I'm still going to get 4. There's no other possible answers I can get because it passed the vertical line test. So if it, for any x I choose, I know what I'm going to get. The opposite of that is if I choose 4 for a y, I have to get 5 for x. I can't get multiple things. So like a parabola is a function, but it's not one-to-one because it fails the horizontal line test. Because if I took a parabola like this and I do the vertical line test, I'm fine. It's a function. Yay, we're happy. So for any x you plug in, you can tell me one y value. So 1x is going to lead to 1y. But if I do the horizontal line test, it hits the graph more than once. So if I plug in y value, I could get that x value, or I could get that x value. I don't know which one I'm going to get. So it's not one-to-one because I don't know what x I'm going to get if I plug in a y. Okay, now this was a little bit on last week's assignment, inverses. You simply swap x and y and solve for y. So if I wanted to find the inverse of y equals 2x minus 3, I would swap x and y and then solve for y. And then I would write this as y to the negative first because it's its inverse. So this function has an inverse of this function. They undo each other. Where people got a little bit confused was if I had a graph that looked like this. We'll say one that looked like this. So that's -1, -1 for fun. This is 3, -1. Oh, I guess this would be +1, not negative. Go away. We'll say this is 5, 2. And we'll say this is -4, -3. Okay. So if I have some function g of x, and I ask you to find g of 3, that's pretty easy to do, right? What's g of 3? -1, because remember this is your x, so when I plug in x of 3, I get that y is -1. A little bit harder though is what is g inverse of 2? Now, this doesn't say find x equals 2 and find the y value. This is the inverse. It's telling you to do the opposite. So what it's asking you is, since it's inverse, what x value do I get when y equals 2? So what x value do I get when y equals 2? 5. So G inverse is asking what x do you get when y equals? And I know that fooled or confused some people.